Hello everyone, in this video we'll be studying about the kinematic synthesis of mechanism. So we'll be seeing what is actually kinematic synthesis. So in first module we have studied the kinematic analysis. Means in first module we were given with different mechanisms and we have conducted the position analysis or velocity analysis by graphical instantaneous interval method, or we have conducted the velocity analysis and also conducted the acceleration analysis. Means we are knowing the complete mechanism means we are knowing the how many links are coming, what is the kind of mechanism, is it a crank rocker or double crank mechanism, you are knowing, and you are finding the velocities of different points or acceleration of different points. That is known as kinematic analysis. And kinematic synthesis, or simply the synthesis of mechanism, is it is actually the opposite to kinematic analysis. So in kinematic synthesis you are not given with any mechanism, you are only knowing that you have to obtain some specified motion, and here we are doing opposite to that of kinematic analysis. That means here we have to design the mechanism based on the required motion. So kinematic synthesis is simply design of mechanism for specified motions. So the different stages or task in kinematic synthesis are: first one is known as type synthesis, second one is number synthesis, and third one is dimensional synthesis. So type synthesis means it refers to the kind of mechanism to be selected. For example, for the power transmission, whether we have to select a gear combination or a belt and pulley arrangement or a cam mechanism we have to select. So this is actually coming under the type synthesis. We are designing or we are selecting the apt mechanism. Or if you are considering a 4-bar mechanism, whether the selected 4-bar mechanism should be a double crank or a double rocker or a crank rocker based on the inversion, or which link should be fixed to get this mechanism. So that is also coming under the type synthesis. So simply type synthesis means what kind of mechanism you have to make or design for this requirement. And second stage in kinematic synthesis is number synthesis. So it is based on the characteristics of the kinematic chain. That means kinematic, whenever the one link of kinematic chain is fixed, it is becoming mechanism. And in this number synthesis, we will be calculating or finding the what should be the number of links in this chain, and what are the type of joint and how many number of joints should be there, and what is the degree of freedom that is coming for the mechanism. So all these things will be coming under the second stage, which is known as number synthesis. So this type synthesis and number synthesis we have already covered in the earlier portions of this subject, mechanics of machinery. And the third one we will be discussing here, or we will be studying here in detail. And the third stage in kinematic synthesis is actually the dimensional synthesis. So here only we are finding it is actually associated with determining the dimension of link. What is the dimension or length of the links required, and what are their starting position, at what angular displacement it should lie, or what is the initial angular displacement between the links. So all kind of dimensional characteristics will be evaluated in this stage. And the third stage is the things which we are going to discuss in this modules. And also we can classify the different synthesis problems which we are discussing, and we can classify it like the synthesis based on function generation, synthesis based on path generation, and synthesis based on body guidance. We will be seeing one by one. Function generation means here we will be having a 4-bar mechanism. Suppose this is the 4-bar mechanism that we have to design based on some requirement. So here there should be one link fixed, so that this can be considered as the fixed link, and then this will be the input link and this will be the output link, and in between this one which is connecting is known as coupler. So whenever it is moving, the input link can be it will make a arc or a path like this, and this will be making some other path like this. So you can consider some variable which are associated with the input curve and output curve. Say the variable associated with the input is x and the variable associated with the output is y. So then you can have a relation between y can be represented as a function of x. Maybe in questions you will have to form a function like y equal e raised to x form. Then based on this requirement you have to find this find the dimension of links. So such a kind of problem is known as synthesis problems based on the function generation. So here you have to form a function between the output and input variable. So this kind of problems are coming under this one. Next one is path generation. Path generation means here also we will be having a 4-bar mechanism of which one link will be fixed. Path generation means any point on this mechanism should be guided through a specified shape. That means if you are selecting, this is the point that you are seeing now, So this is the point that we are taking on the coupler link, and it is mentioned in the beginning that you have to design a mechanism in such a way that this point is tracing a circular arc, or the path may be a straight line or arc or an ellipse, anything can be that. So suppose if you have to trace this point along the circular arc, then that means we have to guide that point on this link of this mechanism through a specified shape, and such kind of synthesis problems will be coming under this case, whereas that is based on the path generation. So that is the second type of one. So in the third type, the entire body should be guided through a pre-selected series of points, and that is coming under this body guidance problem. So example, the buckets of bulldozer will be moving through a series of pre-described points. So these are coming under in such a way that we have to design the mechanism. Then that will be coming under the body guidance, or you can call it as rigid body guidance problem. So the synthesis problems are of different types: function generation, path generation, body guidance, and in our topics we will be discussing some of these cases. And here we will be discussing about another point or another topic which is known as precision points. So we have already discussed one of the synthesis problem which are coming based on the function generation. That means if you are having a variable for input link, that is y, and the output link variable is y, then you will have to form a function between the input and output, that is y equal to f of x. And this function, there will be some actual function which is required, and you will be designing a mechanism or synthesizing a mechanism, and based on that selected dimensions you will be generating a function. Generated function need not be the same as the actual function that we are aiming. So in order to make the generated function as close to the actual function, some points should be selected about which this function should be generated, and that points at which the generated and desired function agree or close to each other are known as precision point, and these points should be selected for designing such mechanism. This one you can understand, or we'll be coming across this precision points in the problems that we are discussing. Maybe in next video we'll be discussing about this one. Anyway, such points are known as precision points. Suppose for example, if you are having some variable x, and this is having different values. It is having some initial value or starting value xi and xf. So in between xi and xf there may be some points which are known as precision points, and about that points only you have to generate the function, that is y equal to f of x, and those points are called as precision points. Suppose in between you are selecting 3 points, x1, x2, x3. So you are selecting this 3 precision points. So this 3 precision points you have to find where these precision points are coming. So for evaluating the precision points you will be using this expression, and this expression is known as Chebyshev spacing. Chebyshev spacing is used for evaluating the position of this precision or accuracy point. So here I will be explaining different terms. Here j is a general variable. J means the number of the precision point that you are finding. So if you are considering a total of 3 precision points in between xi and f, here the 3 precision points I am considering, then total value or total number of precision points n equal to 3. So this variable n is coming here, and j means j is varying from 1 to 3. So j equal to 1 means you are finding the first precision point, this precision point, and j equal to 2 means you are finding the second precision points, and j equal to 3 means you are finding the third precision point. So you can substitute in this equation. So xi is the initial value and xf is the final value, and here cos of pi into 2j minus 1 divided by 2n is coming, where n is the total number of precision points required. And this x1, x2, x3 we will be using in solving problems that we'll be discussing in the next video. So here we'll be finding the sample precision points for an example. Suppose if variable x is taking values between 1 to 3. 1 to 3 means this 1 will be corresponding to xi and this 3 will be corresponding to xf. In between you have to find the precision points, then you can evaluate x1, x2, x3 using this expression. So you can substitute in this one. If you are finding, you will be getting the precision points x1, x2, x3. Here x1 you will be getting 1.134 the x2 you will be getting 2, which is coming at the center of this 1 and 3, and finally x3 you will be getting 2.866. so if you are observing, the initial point is 1 and the first precision point is 1.134. the difference is 0.134, and the last precision point is 3, and last final point of the function x is 3, and the last precision point is 2.86. so here also if you are observing, 3 minus 2.8666, 0.134. so if you are evaluating the first precision point, that is 1.134, which is 1 plus 0.134, then you can automatically find the third precision points as 3 minus 0.134, that is 2.866. so anyway, we will be getting a clear idea about how to use this precision point for design. We can obtain from this next topic, that is where you are using where you are designing a mechanism based on the analytical method called using Freudenstein equation. In that case, you will be getting a better understanding of this precision points. So anyway, this is all about an introduction about synthesis, where we are finding the dimension of links, for which you can use both analytical methods as well as graphical methods.